Example 12.1 Determination of moist air properties. We would like to find the properties of moist air given the dry bulb temperature of 80 degrees Fahrenheit and wet bulb temperature of 67 degrees Fahrenheit. By properties, we mean moisture content, relative humidity, specific volume, enthalpy, and dew point. Before solving the problem, let's refresh our mind about a psychrometric chart. Figure 12.2a that you see here has dry bulb temperature in degrees Fahrenheit on the x-axis and moisture content in grains per pound of dry air on the y-axis, and if we consider the parallel scale next to it, we can get moisture content in pounds of water per pound of dry air. There are a number of lines on the psychrometric chart that I briefly explain them here. The wet bulb temperature line, for which we read the value on the saturation line here, and for example, for the line shown, the wet bulb temperature is 60 degrees Fahrenheit. The relative humidity line, for which the value is in percent. So as you see, the line shown is related to a relative humidity of 60%. Specific volume line with values in foot cube of moist air per pound of dry air. The line here is related to a specific volume of 13 cubic feet per pound of dry air. Enthalpy of saturation line, that these lines are almost parallel to the wet bulb lines. That is why we do not see the slight difference and think they are exactly on each other. The value of the enthalpy of saturation is read on the scale that you see here, and for example, for the line shown, the enthalpy of saturation is 32 BTU per pound of dry air. The enthalpy of deviation lines that are shown as dotted lines, for the line shown here, the enthalpy deviation is minus 0.2 BTU per pound of dry air. Now let's locate a point on the chart with a given pair of data, that is the dry bulb temperature of 80 degrees Fahrenheit and the wet bulb temperature of 67 degrees Fahrenheit, and let's get the point. To find the moisture content, we need to draw a horizontal line as shown and read the moisture content as 0.011 pound of water per pound of dry air, or 78 grains of water per pound of dry air. For relative humidity, we see the point is between the humidity of 50% and 60%, very close to 50%, and we can read the relative humidity for the point as 51%. For a specific volume, we see the point is between the two specific volume lines of 13.5 and 14. We need to interpolate. For this, we can draw a line perpendicular to the specific volume lines, and based on the length of the line segments, we can find the specific volume of the point as 13.8 cubic feet per pound of dry air. For enthalpy, we need to read two values. One is the enthalpy of saturation and the other is the enthalpy deviation. we draw a line from the point parallel to the wet bulb temperature line and read the enthalpy of saturation as 31.6 BTU per pound of dry air. For the enthalpy deviation, we see point is between the enthalpy deviation lines of minus 0.1 and minus 0.2, but very close to minus 0.1, so we can approximately say that the enthalpy deviation is minus 0.1 BTU per pound of dry air. Now the enthalpy is obtained by adding the enthalpy of saturation to the enthalpy deviation and get the enthalpy as 31.5 BTU per pound of dry air. Finally, for the dew point, we can extend the horizontal line that we used to read the moisture content to the left, and from there until it intersects the saturation line here, the line for relative humidity of 100%, and from there go down and read the dew point temperature as 60.3 degrees Fahrenheit. To summarize, we find the properties of the moist air by locating a point on the chart using a pair of data, in this case dry and wet bulb temperatures, and read the properties using the point on the chart.